Lesson 4.1. The main thing that you need to understand from this entire unit, this has to do with linear functions, which means straight lines. If you graph the equation, you'd end up with a straight line. So you need to understand slope-intercept form, which is what I have up here, the y equals mx plus b, which is also known as slope-intercept form. You need to understand what each part of this equation is. So let's start first of all with y. Your y is your dependent variable. Your m is your slope, or the rate of change of the graph. So it tells how steep the line is, and if it's going up from left to right, if it's going down from left to right, or if it's constant. Your x is your independent variable. Your b is the y-intercept, or the initial value. Here I have a word problem, and I want you to come up with an equation that fits this word problem. Now remember, we're going to want it in the y equals mx plus b, which is our slope-intercept form. So let's read it real quick. Now first of all, I have this term IPO in here. This is initial public offering. That's when you have a private company and they're going to go public. They're going to sell stock in their company. They have it, it's called an IPO, an initial public offering. So don't worry about that term here, but let's think about what we would do for this problem. A company gained value at the rate keyword, of $200,000 per day after its IPO of $1 million. Okay, so we need to figure out what is y. We need to figure out m, our slope, x, and our initial value. Well, after its initial public offering of $1 million, tells me, hey, that's this part. Then we have to figure out these. Now, keyword right here, and I stress that, rate of $200,000 per day. That's telling you that this amount is, I just killed a duck. This is $200,000 per day, so days will be our independent. $200,000 is our rate, or our slope, and then that means that this amount of money and at this rate would give us our value, which would be our y. Now I want to use things that are going to make more sense, so maybe what I'll do is I'm going to use v for value instead of y, so I'll say the value of the company is going to be equal to 200,000 times x, but I'm going to say d for the number of days because it would make more sense in this problem, plus its IPO, or initial amount, of $1 million. It's a lot of money. That would be the equation. So let's say you're the owner of this company. And now you want to know, well, how much is my company going to be worth after 30 days after the IPO? Would you be able to figure it out? Sure you can. You plug 30 in for D and then solve the equation. 200,000 times 30 gives you 6 million, plus your initial million is $7 million after 30 days. Whoa, wow! What if I wanted to know how long it would take for my company to be worth $25 million? Then what would I do? I would substitute 25 million in for value and solve for how many days. Whoa, the numbers here are so big that I can barely fit in. So I replaced $25 million for the value. Then what I did is I solved by subtracting 1 million first from both sides. Then I divided by 200,000 to find out how many days. And I get 120 days, or only about 4 months. Man, I want this company. Now, the nice thing here is that as long as you know how to solve equations and you can correctly identify the parts of that, each part of the y equals mx plus b in a word problem, then you could solve for any of the variables. You could solve for your slope, you could solve for x, you could solve for y, or you could solve for b, your initial value, that y-intercept. As long as you can identify the parts in the word problem, you could solve for the one that you don't know. Comparing is something that you're going to be asked to do a lot in this unit, not just 4.1, but actually in all of the sections of this unit. So sometimes comparing can be very easy. Let's say, for example, that in your neighborhood, they opened up 2 vintage arcades. They played all the old games, the Pac-Man and Tetris and all those things that you heard about, or maybe you played an online version of. You're like, man, I want to go there and play those games. So they're offering 2 different deals. Cost of store A is $1.50 a game. Cost of store B is 25 cents a game. Well, there it's a no-brainer. This one's cheaper because 25 cents a game versus $1.50 per game. But what if there was an entrance fee? In other words, you walk in the door, you pay a certain amount, and then you have to play per game. Then how would that change things? Now, store A, still charging $1.50 a game, but it's $10 to go into the store. Store B, or arcade B, is 25 cents a game, but it's 25 bucks to go into the door. And you're like, wow, which one is the better deal now? Well, it's not just a per game cost, so you can't really compare them that easily. What you would have to do is figure out, well, how many games do I want to play? Then you can figure out which one would be the better deal. So for example, if you wanted to play 10 games, 10 games at Arcade A would cost you $15, while 10 games at Arcade B would cost you $27.50. Now you might be thinking, well, of course this one's gonna be better here because, I'm only paying $10 to get in. But if you looked at them graphically, you may find there's a point where one of them's a better deal, or maybe at one point where they're the same deal. So why don't we look at it graphically? Here is a graph of the 2 arcades, and these are their equations to show which one is a better deal at which point. This is very useful when comparing these 2. So if you know a certain number of games you want to play, no big deal. But if you want to try and figure out which one's a better deal for different points, the graphs are great. So look here. This, I said, was the initial value, or your y-intercept. What that means is that your graph starts at $10, then goes up at a rate of $1.50 a game, which means it goes up $1.50 and goes over for each game played. Up, over, up, over, up, over. That's the way we define our slope, and I'll talk about that more in a minute. Here, 25 cents a game, but the initial one is, the initial value is 25, so where it crosses the axis is 25, but here it only goes up 0.25 and over 1, up 0.25 and over 1, so it's not as steep as this one is because this one has a higher rate. So you see that Arcade A, which is the blue one, this one right here, is cheaper than Arcade B until they get to the point of 12 games. Right here they cross. When you play 12 games here or 12 games here, they both have the exact same cost of $28. If you were in Arcade B and you went past 12 games, then you see that this is actually a better deal than Arcade A, because the minute you get past 12 games in Arcade A, even though it's cheaper to get in, the cost is going to be more because the price per game is more. So it really depends on how long you're going to be there. Lesson 4.2. Before I go into too much detail with 4.2, I think it's important for me to talk a little bit more about slope so that you have a deeper understanding of what that rate of change actually looks like when you're talking about a graph. Now you'll see slope written as this triangle y over triangle x. What that means is that delta y over delta x is the change in y values over the change in the x values. And you may also see it written as the rise over run. That's actually an easier way for a lot of students to understand it, because rise they know is up and down, the change in the up and down, over the run, which is the horizontal change. I have 3 different graphs here, and what I want to do is show you how to find the slope for these particular graphs. And then I'll take it a little bit further and I'll show you how to write the equation for them as well. Pretty cool. Let's look at this top one here. Now, before I actually find the slope, I want to point this out too, that if here at the origin, if you're moving up from any point on the graph. If you're moving up though, you're moving in a positive direction. So a vertical change up is positive. A vertical change down is negative. A horizontal change to the right is positive. Horizontal change to the left is negative. That's important to know. But if you remember that this is a number line here, with this being 0, and it goes 0, 1, 2, 3, 4, and 0, -1, all the way this way, it makes sense that this is negative and that's positive. This here is a number line as well. It's just perpendicular to this one. But going up is a positive numbers and going down is negative numbers. That's kind of important to know. So when finding slope, what you do is you count from one point to the other point. Now it's the rise over the run. So some people are like, well, I rise, I always want to go up. Whatever. Doesn't matter, and I'll show you that. Here, let's say I go from this point to this point. What I would do is say, all right, I am going up a +1, and then I have to go to the left to get to the other point. How many places? 1, 2, 3, 4, a -4. The way that you write it is a change in a vertical, or change in horizontal, or the rise over the run. So I have a 1 over a -4. This would be the slope. Now it doesn't matter if I go from here to here or if I go from here to here. Watch. Now what I'm going to do is say, all right, well, I'm going from this point, I'm going down 1, which is a -1. And I'm going to go to the right 4, which is in the positive direction. And I still have a slope of -1/4. Remember, it doesn't matter where the negative is placed. It's a negative fraction. It's a negative fraction. So if it's negative, you learned in the last unit that the slope is going, or that the graph is going down. That's a negative direction. These we would expect to be positive because they're going up from left to right, while this one is going down. So let's try this one. Here I'm going to say, all right, from here to here, I'm going up 1, and then I'm going to go to the right 3. So I have a slope of 1/3. Now, you could choose to go from this point up to this point if you want to. Watch, it still works. So I'm going to go up 1, 2, 3, 4. And I'm going to go to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what is 4 over 12 when it's reduced? 1/3. What? It works. Let's take a look at this one. This one has up 2, to the right 2. Slope of 2 over 2, or a slope that is 1. Okay? In fact, the higher this number gets, whole number, the steeper the graph gets. The smaller the number gets, the smaller the fraction is, the less steep it is. And if it's negative, the same thing applies, but it's going down. Now, let's come up with the equations. So I erased all the stuff and I left just the slopes that we already calculated. Now remember that for a linear equation, the equation that we use is y is equal to mx plus b. What we're trying to do here is trying to find what is the initial value and what is the rate of change. The y and the x do not change. There are independent and dependent variables just like they were in the word problems. So here I have a slope of -1/4. So obviously that's my rate of change. Y is equal to -1/4 x, and then the intercept, or the initial value, is where it crosses the y-axis. So if you look at y equals 8, so you would say plus 8. There is the equation for that line. This one, I have y is equal to 1/3 x, and where does it cross the y-axis? At 1, 2. So plus 2. The last one is y is equal to, now you don't have to write 1 in front. If nothing is there, it's assumed that it's 1. That's important to know. And then where does it cross the axis? Well, if you look, it's at a -4. I could write plus a -4, but it looks better if I just write -4. So it crosses at a -4. Now the graphs are gone, but I left one of the equations up here, and I want to do the opposite. I got the equation, let's graph it. All right, that's easy to do as well. Here I have an intercept of 2, so I would start there. The graph is going to cross here. This is the one that kind of went like that. And then I have a slope of 1/3. Remember, it's the rise over the run. So I would go up 1 over 3, up 1 over 3. Also, I could go down 1, back 3, down 1, back 3. Because remember, it would be negative over negative, which would be a positive 1/3 still. And then down 1, back 3, and this way I'm kind of filling up my graph, and I know that it goes right through here like this. And you could quickly draw an equation from, or a graph from an equation. When finding slope or finding your rate, sometimes it's very clear to understand what is your independent and what is your dependent variable. For example, if you were driving a car, how far you get is completely dependent on how many gallons of gas you have. So, some problems it's clear, other problems it's not. Like this one, for example. You're making lemonade, yum yum, and you use 3 cups of sugar for every 5 lemons. Let me tell you really quickly how to set these up. Whatever is listed first is going to be in top of your slope. It'll be your change in your y. Whatever is listed second will be your change in your x. So when you're trying to come up with your slope, whatever's given, the order it's given to you is going to be your slope. So I have 3 and 5. So my m is going to be 3 over 5. That is going to be my change. Now, because I said that this is my y, because it's my change in my y over my change in my x, that means that this has to be my x value. So if I wanted to set up an equation for it, it would be very easy. Your y value, which is, I'm going to use S for sugar because it makes sense for this problem. You want to pick meaningful variables. Okay, x and y don't always help. The amount of sugar that I would need, the y, would be equal to the rate times the x, which is lemon, so I'm going to say L. Okay? I make it like that so it doesn't look like a 1. So the sugar is 3/5 times L. Here's a sample where we're actually asking you to solve for something. So we have $10 for 4 batteries. How much would it cost for 213 batteries? Well, you need to know your rate of change. And again, exactly how it's given to you is how you're going to write it. So we're going to put 10 over 4. So my slope is 10 over 4. Now, 10, remember this is change in y over change in x. That means this is my y, or my dependent variable, and this is the cost. So I would say the cost is equal to this. Now we keep this, guys, as an improper fraction. We don't want to write it as a mixed number. Sometimes you'll put it as a decimal if you're comparing, okay? But otherwise leave it improper. And then it's going to be times x, but what is x here? It's going to be the batteries. Notice there's no initial amount here again. So if I want to figure out, well, how much is going to cost for 213 batteries? Well, this is B, batteries. I'll put 213 in there. C is equal to 10/4 times 213. And then I would solve. So the cost would be $532.50. But now, what if you said, all right, I have 430 bucks. How many batteries could I buy? Well, that'd be easy enough too. You just got to switch this thing around. So now I have $430, and I want to know, well, how many batteries can I buy? So I put 430 in for cost, and I'm going to be solving for B. When you solve this, you could multiply both sides by the reciprocal, 4/10, or you're using calculators here. You could say, this is 10/4 times B. I'm going to divide by 10/4 on both sides. That would work as well. And then you would find out these would cancel, and B is equal to 172. So I could buy 172 batteries with $430. Don't know what I'd do with that many batteries, but that's how many I could buy. Well, would you look at that? We're comparing again. Let's say you have 3 different stores and there's 3 different rates, and you're trying to figure out which one is the cheapest. Well, there's no initial value, which makes it easy. We don't have to graph. But we need to compare the slopes here, or the rate of change, or the cost per battery, which is what this is. So, how do we do that? Well, it's hard with a fraction. Change them to decimals, then it'll make more sense. So this one here would come out to be $1.25. This one here would come out to be $1.10, and this one would be $1.20. So this store right here has the best deal because the rate is cheapest. Lesson 4.3. In this section, what we're going to do is we're going to graph, and we're probably going to compare yet again, except this time we have initial values. That's the difference. So look here. Adam was given a 3-meter head start and runs at 2 meters per second. The 2 meters per second is our rate, and the 3-meter head start that he was given in the race is that initial value. So when you look at the equation, t is for time, how much time goes by. So if you took time times the 2, which is our rate, plus his head start would give you his distance, or how far he has gotten in the race. Now, if we want to graph this, we know from the last lesson when I talked about slope that we can say, well, there's our intercept, there's our rate of change, and we could quickly graph it. Let's do that, shall we? Remember, this is our y-intercept. This is where it crosses the y-axis. Boop. And this is our rate of change, which means up to. Now, if it's given as a whole number, remember that it's a rise over the run. We can make any whole number into a fraction by putting it over 1. So that means up to over 1, positive. Up to over 1, up to over 1, up to over 1. Or we can say it negative over negative, which is still positive. And that would be down to back 1, down to back 1, down to back 1. And there is the graph. If you don't believe me that this works, why don't we put it into a table and I'll show you that it works. Okay, so I erased the word problem and I put the equation up top with a table down here. So here I have time. Notice I didn't put any of the negative values in there for my time, because what is negative when you're talking about time? Maybe that's when he's still in bed. I don't know about the race and how far he's gotten. So if he didn't start at all, you put 0 in here. 2 times 0 is 0, and he has a distance of 3 because that was his 3-meter head start. If you put a 1 in here, 2 times 1 is 2, plus 3, and you end up with 5. Fill out the rest. Okay, I finished filling out the charts, and now what I want to do is show you that this actually works with what we just did. So here, t, now remember, because this is our y equals mx plus b, right? This is our x value, is our t, and d is our y value here, okay? So if I say 0, 3, that means don't go here at all, but go up 3. Oh my gosh, it's on the line! Then if I go here, 1 and 5, I go over to 1 and up to 5. Oh my gosh, it's on the line! 2 and 7, I bet it'll be on the line. And I go over 2, and I go up 7, and it is. And the same thing with 3, 9. Oh my gosh, Mr. Jones is right. So, it doesn't matter how you want to do it. If you want to set up a table, do a table. If you just prefer to make a graph saying that this is where it crosses, and this is the slope, the rise over run, whatever makes the most sense to you. Sometimes you're given a graph, and the graph isn't very clear. And you can't count from one point to the next point to figure out what your slope is. Let's assume that that's the case here and we can't read this graph. But we're given points. We can still find out what the slope is. If we remember that the slope is the change in the y values over the change in the x values, and we already know that the x value is listed first and the y is listed second, the way you would find it out is by subtracting your y values and subtracting your x values, and you would find your slope, because the change in y over the change in x. You may see it written like this. Your m is your y2 minus your y1 over your x2 minus your x1, meaning you're subtracting the 2 y values, you're subtracting the 2 x values. If you look up here, I labeled this as x2 and y2, and this is x1 and y1, meaning this is my first set, or what I'm calling my first set, and that's my second one. It doesn't matter which one is which. What does matter, though, is that if I say, all right, this one minus this one, then I have to go this one minus this one. I can't do it opposite. I can't say 6 minus 5 over 2 minus 4, going in reverse. It's these minus these. And if I switched it around, it would still work. So let me show you that too. So the first one, I have 6 minus 5 over 4 minus 2, and I get a slope of 1/2. Then if I say, all right, well, I'm going to say this is my first point and this is my second point, then I would do 5 minus 6 over 2 minus 4, and I get negative 1 over negative 2, which is also equal to a positive 1/2. So it works either way, as long as you remain consistent. If you're saying that this is your second set of points, and this is your first, then it's always these minus those. If it's the other way around, then it's these minus those, but you can't intermingle them or interchange them. Now, look at what we said before, your rise over your run. If you go from here, it's up 1 over 2. Up 1 over 2. Oh, it's not marking. Up 1 over 2. Up 1 over 2. Up 1 over 2. Okay? Also, same thing as down 1, back 2, which is what this says. Down 1, back 2. So it works. Now that we know the slope, we could also write the equation for that line. We could say that y is equal to 1/2 x, because that's my slope, plus the y-intercept, which is 1, 2, 3, 4, is where it crosses the y-axis at a positive 4. There's the equation. In this section, you may be asked to compare two graphs as well. We talked about this already in 4.2, so if you forgot how to do it, then refer back to the notes on this particular problem with the arcade games to remind yourself how to do them. Lesson 4.4 is a bit redundant. It's the same old thing that you've done all along with graphing and coming up with an equation from a sentence. The only difference is this is for proportional functions. Now, if you remember from 7th grade math, proportional functions, they have to have the unit rate on them and they have to have the origin, and meaning straight line going through the origin. And when I'm talking about the unit rate, we're talking about the slope. That's what that was from that section that we did last year in math. Well, this year for you guys, but last year in math, we said that it had to go through the origin and it had to be a straight line. So that means that on these, there are no initial value. It'll just start at 0, 0, and then it'll go up at a constant rate. So I'm not going to bother to show any samples for that because you should be able to do that without me showing you anything. Lessons 4.5 and 4.6 have to do with tables. You're given an equation and you're asked to fill out the table. It's that simple. But I want to point out a neat little pattern in the table that if you know, it might help you to fill it out. So first, let's take a look at this one here. Distance is equal to 5 times t, the time I'm assuming minus 3. We have an initial value of minus 3, so we're graphing it. We know we'll cross the y-axis to negative 3. And then here is our rate. So let's fill out this table. And the way that you do it is by plug and chug, which means you take this in for t, and you see it wipes that out, and d is negative 3. And you do that then for here, you put 2 in for d, and then you solve for t. Okay? Go ahead and do that, or else you say, I'm going to go do that real quick. All right, so I filled out my table. Now, this is the thing that I wanted to show you, the pattern. Because this is linear, meaning straight, there is also a direct relationship here that exists every single time. Look, if I go from here to here, I'm adding 1. Here to here, I add 1. Here to here, I add 1. Any guess on this one? Yeah, you're right, it's adding 1. The same thing exists here. What are we adding there? Yep, you guessed it, you're adding 5 here each time. Now, if you remember that this is our x value and this is our y value, and our slope is our rise over our run, or our change in our y values over our change in our x values, then we know that this is our change in our y values over our change in our x values, or the rise over the run. So our slope is 5 over 1, which is 5, which we know is true from the equation. What? In this problem, I'm giving you a table, and I'm asking you to write the equation for it. Wow. All right, well, we can do that. So what I need to do first is find out, well, what is my rate of change, or my slope? Again, the rise over run, I have to figure out what it goes up by and what it goes up by here. So I found out that the x's, or I should say the t's, are going up by 2. Plus 2, plus 2, plus 2, plus 2, plus 2, plus 2, plus 2. And then the y's, or the d's, are going up by 5. Plus 5, plus 5, plus 5. So That means that my slope is the change in the y values over the change in the x values. I have a slope of 5 over 2. So I could set up my equation now knowing that y, d, is equal to the slope times x, which here is t, plus, uh-oh, I'm missing something. How do I find the y-intercept? Two ways. Now, before I can actually show you either method, you have to remember one very important thing, that the y-intercept is where the graph would cross this number line. So, if it crosses at here, y is equal to 4. What is the x value? If you look, x is 0. We didn't move on x at all, we only moved at y. If this was the y-intercept, -2, what is the x value? Again, it's 0 because we didn't move on the x at all. That you have to remember, that your y-intercept is when x is equal to 0. Method number 1. Here I got rid of the last section of the table and I left 2 blanks here. And I did that because here, if you remember that adding 2 going that way, adding 5 goes that way, well, it also works in reverse, meaning you subtract 5, subtract 5, subtract 5, subtract 5. And if you remember that the y-intercept is when x is equal to 0, then what you do is you keep subtracting until you hit 0 here. Meaning, now to go from here to here, I would subtract 2 because I'm going to the left. 2 minus 2 is 0. Oh, my x is 0. So that means if I take 5 and subtract 5 here, I get -3. There, my x value is 0. That's my y-intercept. So d is equal to 5 over 2t plus, or I should say, minus 3. And that would be the equation. That's method 1. For method 2, I'm going to take any point from the table. Now, what I'm going to do is I'm going to leave this equation up here because this is what we got, and I want to show you that the other method works as well. So I'm going to take maybe this point right here, 4, 7, and I'm going to write it as an ordered pair, 4, 7. And then I'm going to show you method 2. To make myself a little bit of room, I erased the table. You see, here is the initial one that we had, where we said it's -3, and here's the point from the table that I kept. So this is what we're going to do. Remember that this is your x value, or in this case the t, and this is your y value, or in this case the d. And what I could do is I could substitute these points, because those points have to be on the line. I could substitute them into the equation then, and solve for b. 5 over 2t, which is 4, woo, that looks messy, plus b, and then I could solve for b. Okay, so what I did is I took 4 times 5 over 2, and it's 4 times 5 is 20 over 2, that becomes 10, then I subtract 10 from both sides, and b is -3, and wow, it works! Now I know some of you are saying, well, I don't like that method because I don't like solving equations. But what if you had a table that was huge and working your way all the way back to 0 took a very long time? Then this method is kind of quick. Look what's back again, comparing. Well, if you want to compare and you are given 2 tables, then what you need to do is come up with the equation, you plug in the value that they're giving you, find out what's a better deal. If they're not saying which one's a better deal, then you might want to graph them and see which one's a better deal over long run, but more than likely they're going to give you a value and say which one's a better deal for this point. So lesson 4.6 is exactly like 4.5, except we're dealing with proportions, which means that it's going to go through the origin and there is no initial value because there's 0, 0. Meaning that when x is 0, y is 0, there is no initial value. So straight line again, except there's no initial value. So these should actually be a little easier. Okay, it's review time. For this test, you're going to need to know how to do all of these things. It's really not a lot. First one, you're given a sentence and you have to, from that sentence, find the equation. The rate of change is what ROC is, which is your slope. The initial value or your y-intercept, your dependent, your independent variable. But if you know the y equals mx plus b and you know the parts, then that's not a big deal. Then you're going to be given an equation. You're going to be asked to solve word problems. Let's just put the numbers in and tell me what you get out of it. And then here is a mix of these two things. So in other words, you're going to have to give a sentence, you're come up with the equation, all these different things, and then also answer a question. Then you have a sentence, and you're going to have to give the equation and the graph, and you're going to have that with and without initial values. So one will be through proportional, will be through the origin, the other one will not, it'll have initial value. You have to answer questions from a graph. So if graphs, can you interpret it? Can you tell me what these points are? If I give you this one, can you find this one? And then given an equation, give the equation from a graph and table is what you're going to have to do. So you'll be given a table, and you'll have to give what the equation would be. That would be from a graph and a table. You have to fill out tables. So that's where you have when you have some blank spots. You have to find the pattern and fill out the rest of the table. You have to compare three things. One of them is given to you in his equation, one's given to you as a table, one's given to you as a graph, and you're going to ask which one is the higher rate, which one has this, that, and how do you know? So you're really going to have to understand those three things and how they relate. And then the last part is slope from points. So I give you a set of points, and you have to subtract the y values over the difference of the x values and tell me what the slope is. It's a multiple choice dealio. That's it, my friends.